Today, we're going to be learning about topographic maps. Make sure before you get started, you have your topographic map note page ready to go. Be sure to pause the recording as often as you need to make sure you take the notes correctly. Anyone who knows how to read a topographic map can actually see the landscape of a region without being there. A hiker could look at the mountains and valleys and plan the best route for a mountain climbing trip. An engineer could plan the best location for a road or a power plant. A tourist can get an idea of what they're going to see on their vacation. Mapping is an important part of earth science. Topographic maps use a line called a contour line to show different elevations on a map. As you see in the picture, there's lots of wavy lines going across the page through the map, and those are your contour lines. They show the location of hills, mountains, and valleys. A regular road map shows where a road goes, but the map doesn't show if the road goes over a mountain pass or if it goes through a valley. A topographic map shows you the features the road is going through or past. So let's take a look at some topographic maps. Before we do that, look at this picture here of the Swamp Canyon Trail in Bryce Canyon National Park, Utah. You can see in this picture, there's some rugged canyon walls and a deep valley below. The terrain has many steep cliffs with high and low points between the cliffs. If you were looking at the regular visitor's map for this same section of trail, you can see the green line on the map that's your road. You can see the black dotted lines that are the trails. You can see some marks for campsites, a picnic area, and a shuttle bus stop. The map doesn't show the height of the terrain. If you were visiting here and you only looked at this map, you would have no idea about the hills and valleys you're about to encounter. How high are the canyon walls? Which way do the streams flow? A topographic map will answer all of these questions. Here's a topographic map of that same area. This represents the elevations in the area. If you look at this, you can still see, you can tell where the hills are and where the valleys are. It's pretty easy to read once you get the hang of it, so let's do some practice. Topographic maps are used most often for navigation, so hikers and explorers can get a sense of the terrain. This helps them look at a flat, two-dimensional map and see where the hills and the valleys are. Scientists use these to observe things based on their location and elevation, and pilots use them as well. Starting with your notes right now, go ahead and get ready, get your pencil ready. Topographic maps show how flat the land is or how steep the land is. They allow you to see a three-dimensional landscape on a two-dimensional map. These maps define the natural and man-made features like hills, valleys, vegetation, water, trails, bridges, and roads. These curved continuous lines that you see are called contour lines. Contour lines are drawn on a map connecting points of equal elevation. Contour lines show the elevation and the shape of the terrain. Everywhere along this dark green line is 100 meters above sea level. Everywhere on this dark green line is 200 meters above sea level. If you actually walked along a contour line, you would never walk up or down a hill. Everything along this contour line is completely flat. So contour lines show very steep slopes and very gradual slopes. When you see contour lines that are very close together, that means that it's a very steep slope. So if you look right here, they're very close together. That means that the mountain itself is very, very steep. Contour lines that are farther spaced are more level terrain. If you look at this right here, because it's spaced out so far, this is very, very level or gently sloping. So this area would be relatively flat, while the contour lines very close together here would be very steep. Over here would be very steep. As you can see right there, steep, more gradual across the center. So we know that contour lines are the continuous lines that run on a contour map. But the contour intervals is the vertical distance up or down a hill between the contour lines. Usually they draw every fifth line darker because it just makes the map easier to read. So if you look here, this is 700 feet, this is 800 feet. We need to figure out what the contour interval is. In this case, it looks like it might count by 20s, 700, 720, 740, 760, 780, 800. So that tells us that the interval, kind of like the range, is the distance between the lines. Contour topographic maps can have many different intervals. They can count by hundreds, they could count by tens. It's up to you to figure that out. Let's take a look at this simple topographic map. If you look at this map here, it shows our contour lines, all these nice connected lines, which represent the same elevation. The contour lines represent changes in your elevation or height. Remember, the closer they are together, for example, down here, the steeper they are to the land. If you look here, area A is much steeper than area B because the lines for area A are much closer together than area B. This marker tells us the elevation in either meters or feet. The contour interval, remember, is the distance between the contour lines. In this case, we have 100. The fifth line is 1500. So we could figure out that this map is counting by 100s. The contour interval would be 100. So 1000, 1100, 1200, 1300, 1400, 1500. Sometimes topographic maps even show details such as water and buildings. Now, in our watershed unit, topographic maps are important to us because we know water flows downhill. So we can look at a topographic map and know which direction the water is flowing. Take a look at this map here. You see 3 mountains, Peak A, Peak B, and Peak C. If you are getting ready to hike one of these mountains, which mountain do you think is steeper? Remember, steeper lines are always shown closer together. It looks to me like Mountain B is steeper if you're coming from the backside of the mountain. Now, if I were to hike this mountain, it looks like if I was going to hike up to the peak of B, probably to come from the front side of the mountain would be a much easier walk. I can tell that because the contour lines are not spaced nearly as close together. At this point, you should have all your notes, and it's time for you to take a look at the next section in the hyperdoc, and that will have you answer some questions to practice. After your questions are answered, please show them to Mrs. Tuckash so we can make sure you're on the right track before we move on.